Okay, so I'm back here for the back of your notes. Okay, and again, you'll need a scientific calculator for this. So if you don't have your scientific calculator at home, at least have your phone out, and hopefully your phone has these two buttons. You'll see a button that has log on it and a button that has ln on it. Both of these deal with logarithms. Okay, and I'm going to show you how to use those buttons here. So if you just type in log 6 into your calculator, you should get an answer of 0.778 and so on. It'll be a big long decimal, but that's what you should get. Then if you type in ln of 5, you should get 1.609 and so forth. But what does that mean? Okay, well, on a calculator, they give you two specific bases. This really means log base 10 of 6. Okay, so remember this is an exponent. So this is saying essentially that if you raise 10 to the 0.778 and so on power, you'll get 6. So that's what that button does. The log is always base 10. Now, natural log, that's what ln stands for. It's natural log. That's log base e. So this means log base e of 5, which means if I would raise e to the 1.609 and so forth power, I would get 5. Now, the reason this is why it's called the natural log is because e is the natural base. So your calculator can only do those two bases, either base 10 or base e. That's it. So on your calculator, down here, if you wanted to find the log base 10 of 7, we could do that. Again, into your calculator, you would just type log 7, because that's what base 10 means. It's understood. If it's not there, it's understood to be 10. So that's the log of 7, and you should get 0.845. And we're always going to round everything to 3 decimal places. So on your test, on your worksheets, on everything, it's going to be 3 decimal places. And then log base e of 12, again, that just means ln of 12. And that's going to equal 2.485. So your calculator will do log of 6, that's log base 10, and ln of 5, that's log base e. So what happens, oh wait, I'm getting ahead of myself. Here you go. This one is for you to try. Okay, I forgot about this slide. So go ahead and type these into your calculator, round all of them to the nearest thousandth. If you want to pause the video and go ahead and do that, you can. But it's just practicing typing in what button to do. Okay, so log base 24 should be 1.380. Natural log of 2.78 is 1.022. Now for this next one, when you're subtracting, make sure you end your parentheses. So you should have natural log of 7 minus natural log of 2. And again, depending on what calculator you're using or what your phone, I'm not exactly sure how it's going to look, but your answer should be 1.253. For natural log of negative 10, you actually get something that's undefined. Okay. And that's because this is really saying natural log is log base e of negative 10. So this is asking for e to the what gives you negative 10. Well, that's not possible. E is a positive number. E is 2.7. No matter what I raise it to, it's a positive number. I can raise it to a fraction. That just means I'm going to take the square root, but that square root's still going to be a positive number. I could take it to the negative number, like e to the negative second. That's just a negative exponent just puts it in the denominator, but it's still a positive number. So there's no exponent in the world that could possibly make this a negative 10. It's just not possible. That's why it's undefined. And it will be undefined. It's not going to be doesn't exist or NA or any of that. It's going to be undefined. Now this next one, log 25 minus log of 21. Again, make sure you're putting in your parentheses. You should get 0.076. And finally, this one here, you had the two different bases, natural log plus log of 38. And again, make sure you add your parentheses in there. So you should get 3.659. So if you're unsure, if you couldn't get any of these, retype them in. If you still can't get them, shoot me a quick email and we'll try to figure out what's going on with whatever device you happen to be using, calculator or phone or whatever. Now, the question becomes, well, what happens if we have this? Log base 4 of 6. My calculator cannot do that. It does not have a different base besides base 10 or base e. So, change of base formula. This allows us to change our base. We want to change it to either 10 or e so that we can plug it into our calculator. So what the change of base formula says is it says, let's say I have log base, let's just say a of b. I can change this to log base c of b over log base c of a. So notice my argument right here becomes the argument of the numerator. The base becomes the argument of the denominator. And now what's this c? Well, the c is whatever I want c to be. I'm changing the base, so I can change that to be whatever I want. So since my calculator only has base 10 or base e, that's what I want to change it to. So when I come down here, I can either change this to log base 10 of 6 over log base 10 of 4, or I could change it to log base e of 6 over log base e of 4. So that means in my calculator, I'm either going to type log of 6 over log of 4, and don't forget parentheses, or I'm going to type in natural log of 6 over natural log of 4. Either way, and you can test this to make sure, either way, you're going to get 1.292 for your answer. So, change of base formula tells me no matter what log I have, if I want to plug it into the calculator, I have to change it to log base 10 or log base e. And again, your argument becomes the argument of your numerator. The base becomes the argument of your denominator. And then your new base is whatever you want it to be. We could have changed it to, let's see. If we wanted, we could have made it log base 8 of 6 over log base 8 of 4. If I wanted to do that, I could have. It's just not going to help us. We need to plug this into the calculator. So this is possible, but not necessary. So the log base 10 and the log base e, that's what I want to do. So for this last slide here, go ahead, use your change of base formula. I'll do the first one with you. So you can choose natural log or you can choose log base 10. So if I chose natural log, I'm going to type in natural log of 12 over natural log of 8. And when you plug that into your calculator, you should get 1.195. And again, if you're not getting that, don't forget to add your parentheses in after that 12 and then divided by natural log of 8. Now, again, you don't have to use natural log. You could use log base 10. If you wanted to do that, this one would be log of 768 divided by log of 6. And when you do that, you should get 3.708. So now if you want to pause the video, try the last 4. Remember, we're rounding everything to 3 decimal places. Go ahead and give it a shot. Then you can restart the video and see if you got them right. So this one should be 3.644. This one over here should be 3.483. This one should be 1.267. And the last one, even though they're really big numbers, it's just going to be 1.728. Now, don't forget what you're finding. You're going to hear me say this over and over, but logarithms are exponents. So just for example, what is this one asking? This one is saying 11 to the what power is going to give me 6228. Well, that exponent is 3.644. And you can test it on your calculator if you want. But that is saying that 11 raised to the 3.644 power is going to give me 6,228. So that's what logarithms are. They are exponents. They're telling me what exponent the base needs to equal the argument. Okay? Again, if you have any questions, please feel free to email me or rewatch the video or come to my office hours. The homework worksheet is just this, doing the calculator stuff and the changing from exponential to logarithmic form on the worksheet. So again, if you have any questions on any of this, please let me know. Have a great day.